Zach here. So today I'm going to walk through what I'm calling my execution environments crash course. So recently I've been helping a lot of customers who are getting their Ansible Automation Platform environment stood up and starting to write playbooks and kind of getting to that inflection point where they're needing to use some of their vendor collections that aren't included in the supported execution environment that Red Hat provides out of the box. So they're needing to build custom execution environments. We have a lot of tools set up by Red Hat to help us do this, but the documentation, I know everybody consumes things different ways, right? So the documentation may not be great for someone who likes to kind of see it in action. So that's what I'm hoping to do here with this post today. So I'll start here just with a quick overview of kind of what this strategy looks like for execution environments and what I generally recommend, and then we'll dive into some of the details. So first off here, the post here is in the video description, the link, but you'll see I have a step-by-step tutorial here, so that's what we'll go through later on. But to start, I just want to go over some strategy. We get a lot of questions from our customers around this, specifically kind of, how many custom EEs do I need? Is there a ton of effort required for me to maintain these? I really want to focus on the automation. So what I've done here is, I'm not going to go through all these questions, but if you come here, you kind of read through questions that we generally get and the suggestions I like to give. I think most importantly, the high-level recommendation is try to keep your EE footprint small, but make sure that you do enable your teams to complete all the automation they need to. And if you read into these questions, you'll see kind of where my opinion comes from, and feel free to comment on the video if you have questions. So scrolling down here, just is some of the tools that we're going to use in this crash course. So Podman and Builder are the basis of Ansible Builder, which is actually going to be used to create the execution environment image, which then AAP leverages to spin up containers based off of that image to actually execute your Ansible playbooks. So the too long don't read here is Podman as a container engine backing Ansible Builder, and Builda helps with some of the build processes when Podman is going through and actually building an image. So down here, so Ansible Builder, right? This is the Red Hat provided tool that effectively makes it easier to generate the artifacts that Podman needs to go ahead and build the image, right? So Ansible Builder is specifically focused on execution environments, and more recently decision environments for event-driven Ansible. The way that Ansible Builder works is it consumes a definition file, and then you can also add in additional files into what we call the build context for more complicated image setups. But at its bare bones, it just needs a definition file that we give it to say, here are the dependencies I want. So let's scroll down here. We're going to dive deeper into this in the next part 1 of the series, but this is what a definition file looks like, right? You can see we have some options we're setting, base image, and then our dependencies. And lastly, I'll kind of give a high level of what these dependencies are. So the three types of dependencies you can define are system level. So these are going to be your binaries installed by the package manager, which is going to be determined by the base image you choose. Then we have Python dependencies. So these are any Python libraries that you need to execute your automation. And lastly, we have Galaxy, right? This is the fun stuff. This is the Ansible, the collections that you want to download and leverage in your automation. One really cool thing about Ansible Builder is if you use Ansible Builder to build your execution environment image, it greatly reduces the amount of Python dependency explicit definition you have to do. So the collection should have their own requirements.txt that define the dependencies for their collection. And Ansible Builder is smart enough to go ahead and follow through and not only download the collection that you need, but also any Python dependencies that come with that collection. So it should save you a lot of verbosity and as far as like what you have to define to get this custom execution environment built. And then additionally, you just want to show this is how you inject a custom Ansible config. I highlight this step specifically because this is something you're probably going to want to do, right? When we're building execution environments, we generally don't want to just be pulling information from public Ansible Galaxy, at least not in enterprise environments or corporate environments. Maybe in our home lab, no big deal. But this is the way that you can actually inject a custom Ansible config that has credentials to your private automation hub, or has your credentials to access Red Hat's automation hub that we host for our customers. Lastly, I'll just breeze through these, right? Defining your base image. This is an important step. I always recommend using EE minimal, and then your RHEL version, and then your Ansible Automation Platform just depends on the version of your platform that you're running. I'm currently running 2.4, and 2.5 is coming out later this year, which is exciting. And then options. So one kind of thing that you might trip up on, I still trip up on it every once in a while. The default package manager that Builder looks for is DNF. Even in EE minimal, we actually have micro DNF. So you'll run into that error if you don't specify the package manager path. If you were to use a different base image with a different base OS, boo. But if you do, make sure to specify the path for that OS's package manager. All right, so that's it for the overview. Next, I'm going to actually dive into the part 1 of the series where we'll actually build out a definition file in detail. All right, everyone, so here we're going to get started on part 1, which will focus on just creating the definition file for building an execution environment. So before we get started, let's go ahead and set up our environment, make sure we have the prereqs. So the minimum Python version you're going to want to have is 3.9. And this is to support the latest version of Ansible Builder. So I'm going to go ahead and check on my RHEL host here. That's going to be my build server. What Python version I have. Looks like I have Python 3 is defaults to 3.6. Let me see if I've installed 3.9, which I hopefully have because it's my build server, and you can see that I have it. And let me check my Ansible Builder -- version, and that is what I expect. So you'll want 3.0.0 or 3.0.1 at the very least. And I highly recommend having a build server, so not running this on your local host, having a RHEL server somewhere else that you can connect to and do these operations. This will be extremely useful, especially when we get into the automation process, where we can have Ansible use a build server to actually do the build process, and then push the execution environment images to the appropriate places. So the other thing that we could install that I'm not going to focus on in this course, but Ansible Navigator, that's going to be a really useful tool for inspecting your execution environment images. So let me go ahead and clear my terminal here. We're going to go ahead and set up the build directory. So I've already created one. You can see here it's called Ansible Crash Course. Let me do tree real quick. So I've got these files here. I've got this execution environment.yaml, created a files directory, and then an empty ansible.config, which will populate in a minute. So let's now focus on the execution environment.yaml. I'm not going to cover everything that you could possibly put in here because that's just not realistic, but I'm going to try to focus on the common use cases that I see with customers, and then you can view the full schema in the document. I have a link there. So to start, let me just go ahead and put version 3 because this is the builder schema version, has nothing to do with the version of the execution environment. And then we'll start with our images, and we'll define a base image. I always recommend using the Ansible Automation Platform version you have. So for me, that's going to be 2.4. And then EE minimal your RHEL version. And then I'll go ahead and put the latest tag. So that's going to be the base image for my execution environment. It's going to determine the OS and then some of the other packages that may be available. So for options, this is an important one. It's kind of a gotcha. So the default package manager path is going to be user bin DNF. And if you're using the minimal base image, there actually isn't DNF. There's only micro DNF. So you would run into an error there on that step. And it can be perplexing, but this is how you get past that error, is by specifying your package manager. If you are using a base image with a different OS, shame on you, but if you are, just make sure that you specify the package manager path for that OS. So next steps, this is kind of the fun part, our dependencies. So what do we want to add into the execution environment to support our automation? So I'll start with system. So this can be your binaries. In this case, I'll just do git, right? Go ahead and add git into my execution environment. I could put other things in here, right? Really any system tool that you think you might need. And then for Python, I'll go ahead and specify JMES path 0.1 10.0. JMES path is nice for like querying complex JSON objects and kind of doing getting to the root of things and basically writing a query against JSON. And then Galaxy, so these are going to be the collections we want. I'm going to keep this super simple for the demo. And I'm just going to say, give me the, extra in there, give me the Ansible.controller, and then version 4.5.1 is the latest version, I believe. I always recommend specifying the specific version. You can do things like greater than or equal to, you know, or you can do greater than, you know, so you have those options, but I like to keep it as a specific version. That way, when I rev this execution environment definition and I tag my image later with the commit hash, I basically have a snapshot of, I know what the execution environment tag is, and I can go look at the commit that matches that hash, and I can see exactly what was in my image. If I had like a greater than sign there or greater than or equal to, I could be somewhat sure, but not completely sure what was in there. All right, and then last steps, we're going to do additional build files, and this is specifically so that we can add in or inject a custom Ansible config to pull from our private automation hub. So what are we doing here? I'm saying the source is files, so that's going to be local to where I'm building the image from. So you can write, I have my files directory here that I set up, and then destination is configs. So that's going to be the destination within the build context. So then additional build steps, we're going to actually consume the files we just copied. So there are a few different lifecycle hooks. In this particular case, I'm focusing on prepend Galaxy because we want to inject the Ansible config before we try to download collections. And I'll add a copy. So this is actually like Docker file, container file syntax here. We're actually adding a layer into the execution environment container file. And I'm going to say copy from build, which is our build context, configs, right, which is the directory we copied files to, and then ansible.config. I'm going to put it in etc ansible.config within the build process, so that when it goes to download collections, right, that's the default location it's going to look for my config, and it'll have the proper Galaxy server information to pull down collections. So go ahead and save that. And if you scroll down here in the documentation, you get some details, right, of everything I just talked about. So let's go down a little bit further, and we're going to go ahead and create an Ansible configuration file. I've got an instruction here for how you can get an API token for your automation hub. I'm just going to use a fake token for the demo, but this is what you would do, right, is just go to your automation hub, the API token section, and click load token, and then kind of copy and paste it. When you do this, though, it does invalidate if you had a previous token that you were using. So one of the places that I always recommend going to check and make sure and update if you do need to regenerate is these 4 credentials that are going to be in your controller out of the box. Go ahead and make sure you add that token to these credentials, just to make sure that they stay in sync with your automation hub. So then I'm going to go ahead and copy and paste, instead of typing this all out, into this ansible.config file. So in here, what have I done? I've just created an Ansible config that has Galaxy server information, and I've created a list, right? So this is a list of priority order that I want it to look in. So I'm pointing at the Red Hat certified, then the validated, then published, then community, within my private automation hub. So the builder process is going to look in those different repositories in that order to find a collection, in this case Ansible.controller, which is going to come from Red Hat certified. If it didn't, it'd move on. And then private automation hub community is kind of a special one. It's technically content from public Ansible Galaxy, but it's content that you've approved and synced into your private automation hub. So a way to control what community access your teams can actually use. So scroll down here, a lot more detail there regarding how these repositories interact with the build process and how you can take advantage different available content to you. So I'm going to pause here. This is really all we needed to do to set up the definition file and associate Ansible config. Obviously, fill in this information with your Automation Hub host and Automation Hub token, and then we'll move on to the next step where we'll actually build an execution environment. Hey everyone, so now we're going to start on part 2, and we will be actually creating an execution environment. So after we've completed part 1, our directory should look like the following on the left here. So let me go ahead and type tree. So you can see I've got my execution environment.yaml, and I've got my Ansible config. Below are a couple of set commands you can use to replace the tokenized variables with your information. So your automation hub host, and then your automation hub token, which I have instructions grab. I've already done that. So the next step I need to do is go ahead and log into registry.redhat.io. So I'll do that with podman login. This is going to be used to pull the base image because I've already logged in. Before we run the build, I do want to just quickly note that if you watched me in part 1 and copied what I was doing as opposed to the documentation, I made a quick typo. So let me go back into the execution environment.yaml. And you'll notice I had the base image set to the name of the image itself. We need to go ahead and indent that and set it to this name key. This is just the schema. I had it out of whack. If you copied from the documentation, you will be just fine. So the next step is going to be to go ahead and run builder. So let's do that. I've got a command here where I'm going to tag it with latest, and then I'll tag it with v1, and then this final v3 is just for verbosity during the build process, kind of see what's going on. So we'll let that run, and I will see you in a moment. All right, looks like our build process is done. You can see that it tagged it as Crash Course Latest and V1. I'm going to do the full commit SHA, so let's scroll down here. The next thing we're going to want to do is go ahead and push to Automation Hub. So let me just go ahead and run a podman images, see what we've got here. You can see that I pulled down, because of the base image, right, we've got our E minimal rel 8. On this machine, I had pulled down some other things. So you've got this E supported rel 8 and this other one as well. But here are the two we just built. Two different tags with the same image, right? You can tell by the hash here. And now what we want to do is we're going to actually give them a new tag, and we're going to push that tag to Automation Hub. So I'm going to give it localhost, which is the current tag, v1, and I'm going to tag it as my Automation Hub URL with the same name, and v1, right? And I will do the same thing, and I will do latest for the tag. That way I'm just creating new tags, right? So not new images. That's why it's an instant operation. And if I do podman images again, I should see a longer list, right? And I've got my two new tags. So now I'm gonna go ahead and log in to the private automation hub host, which will use that same host that you just used. So you're just the host name. So again, you could use a local username in the automation hub and then a password or a token to do this. But make sure you do log that so that we can then do podman push, and then automation hub e crash course v1. And then after we push v1, we'll push latest just to have both tags up in automation hub. And the first one will actually take some time, right? Because it's pushing the layers that don't exist in that particular registry. And the second one should be pretty quick because it's the exact same image. So let's run it again, and we'll switch v1 to latest. So you see everything already exists, so it skipped most. Now let's go over to our automation hub and look at the image. So I've already got the images pulled up. Let me refresh, make sure I have the latest images. We added a new one here. It was at 24. Go find my EE crash course. And if I go over to images, just like that, you can see we've got our new image pushed, and we got our two tags, latest and v1. So last step here is we've got an automation hub, but we don't actually have a reference to it in controller. So let's go to our controller instance and go ahead and log in here. So let's go over to our controller instance, and I'm going to go ahead and open on the left here, go to administration and execution environments, and I'm going to add one. So I come back here, I've actually got a picture of all the things that I'm going to fill out here, but I'll go ahead and just walk through it over here. So I'm going to name it just same name. This name is arbitrary. If you want to have different naming convention in your controller, that's fine as well. But this is just this is what it'll show up when you attach it to a job template. The image name, now this isn't variable, right? It needs to be the name of your registry host, and then EE crash course, and then a version. I never recommend pointing at latest because one of the pitfalls is that an execution node, if it has the latest version, it won't actually try to pull latest. So even if the hash changes for the latest tag, if the execution environment, or if the execution node, which is responsible for pulling the image down, has latest, it won't realize that there's actually a newer version of latest. So I always recommend using a version. And then I always say only pull the image if not present before running. If you're using the API, there's a keyword called missing, which reflects that option. I'll just leave this blank, make it a globally available. And then I'm going to specify a credential, which is my credential to Automation Hub, which allows me to pull down that image and then give it a meaningful name, right? We completed EE crash course. So give a description and save it. So that's it for part 2, right? You have now created an execution environment image, you've pushed it to Automation Hub, your private Automation Hub, and then you've created a reference to it in Ansible controller. And you can take advantage of things like RBAC to kind of control who has access to this execution environment. And via that access, you control what access users have to automation content, right? Because you've baked it into the image. So thanks for listening. Take a break, and then let's move on to part 3, where we will go ahead and talk about how you add stuff to it and start to curate a purpose-driven execution environment for your workloads. All right, let's start with part 3. So now we're actually going to update the execution environment that we created in part 2. And if you remember in part 2, it was super simple, right? We had like 1 or 2 dependencies. Really not a functional EE at that point, didn't have a lot in there. So the goal for this example is talk about how you can curate an execution environment for a purpose-driven workflow. Recently, Windows automation with Ansible has become really popular. A lot of enterprise corporations have big Windows footprints, and Ansible has done a lot on the development side of things to be very compatible and useful for automating Windows servers. So right now, we don't really have any Windows collections in our execution environment, and that's not good. So we have a couple options here. I'm actually going to start with the bad one, then I'll come to the good one. So the bad one is we can add a requirements.yaml file to the repository that our playbooks are in, and we can actually download collections during project sync. So as long as we set up the connection from Ansible Automation Platform, the controller, to let's say like Public Galaxy or our private Automation Hub, we could actually do it at project sync and download them. This method, though, adds unnecessary time, right? Every time you do a project sync, you're actually going to be just downloading collections, right? It also kind of opens things up a bit, right? So your developers can specify collections in a requirements.yaml that you may or may not want them to be downloading. So the good method, right, is to go ahead and add anything that makes sense for a purpose-driven workload to our execution environment, and then build and publish a new version. If we do this, we can actually disable collection downloads, right? Which adds an extra layer of security in our controller. People can't download just random collections using a requirement.yaml file. And it also just keeps things focused and contained within the execution environment, and no unwanted outside content can come in, right? So I'm going to walk through using this method. And I hope that you're able to, at the beginning, right, it may not make sense for your organization if you're changing too rapidly, constantly having to add or remove things. But once you get to a stable point, teams that need new content, right, that should be a request process where they come through, they ask to update an execution environment, or they're managing it themselves and they make that update and push a new version. So let's scroll down to add content. We're really just going to edit the definition file, right? So the point of this is just to show it's not that hard to manage and maintain these. And you can see the diff below for the changes that I'm going to make in this example. So we're going to add a few Windows collections that are relevant to Windows workloads. So let me go. I'm just going to copy and paste it from here, actually. I'm going to scroll down. I'm going to paste them in. I'm going to have to do some editing. But let me go ahead and delete our plus sign. I think that's all I need to delete. A little extra one there. So now I'm going to save this. So in this execution environment, you can see I just added some collection dependencies. So any of these collections, again, that have dependencies on additional Python libraries, which some of these do, like PyWinRM for connecting to Windows host, those will be downloaded as part of this process. I don't have to specify them in the Python dependencies list. So I come back here. As you can see, the next steps are actually pretty similar to building the EE, right? There's no real changes here. The only change is going to be the tags we give it. So we're going to tag it again with latest, right? Move the latest tag forward. Then we'll tag it with a EE Crash Course v2. So let's come back over to VS Code. I've got a terminal open down here. And I'm going to run that Ansible builder command. I'm going to update that version here from v1 to v2 and just let it go. So again, once this is done, I'll come back and we can talk through pushing that change to Automation Hub and updating controller. All right, so at this point, you guys might actually already know what to do next, right? So we've got our new image version tagged with the localhost EE Crash Course latest in v2. So we're going to go ahead and retag those with our Automation Hub host and EE Crash Course, and I'll do latest. Oh, I forgot to put, before that, right, we have to specify the existing image, so localhost EE Crash Course. We're going to tag that. And then we're going to do v2, and we'll do v2 here as well, and run quick pod my images, make sure everything's good to go. We've got our v2 tag and our latest tag, and now we just push. So I'll go ahead and do automation. Let me just copy and paste it here, it'll be easier. Apologies for my slow typing. Let's push latest. So it's a new version, right? And I could have pushed v2 first or latest, doesn't matter. We're going to push the second one next. One of them is going to be pushing. One of the cool things with containers and images, right, is only having to push the layers that changed. So it's not actually having to recreate every layer that exists for this image. So now I'm going to push the v2 tag. And now let's go look at our Automation Hub. Let's click on this image, give it a little refresh, right? We just pushed a new version, and awesome, right? So you see we've got our latest tag moved up, and it's now pointing at v2. And the last step would be then to come back to controller, and we're going to edit our EE Crash Course here, and point it at v2. So what would happen now is that any job template pointing at EE Crash Course execution environment, behind the scenes we've changed the version, the job template doesn't care. When Ansible goes to launch a job, the execution node is going to say, hey, I'm missing this version, pull it down, and then run. So that's how you update your EEs, right? That's how you add cool content to them. And this is a really good process. We walk through it manually. Part 4, we're going to actually talk about how you can fully automate this, where the only thing you have to do is change the definition file and commit it to a Git repo. And then we'll kick off an Ansible process that'll actually do all these, Ansible builder steps and then the Podman steps and things like that. It will also update your Automation Hub and your controller. All right, so join me in part 4. Hey everyone, so now we're going to go ahead and walk through part 4. So automating this entire process to where the only thing we have to do is make a change to a definition file. So what I've done is I set up a skeleton repository that you can go ahead and clone in GitLab. It's publicly available. And I've given you the Git commands to go ahead and do that on your local machine. So the first thing though you'll probably want to do is create just an empty GitLab project and give it a meaningful name. Make sure you uncheck initialize the repository with a README, right? Because when we push code, we don't want there to be any existing commits on that repository. And then once it's created, you'll get some information about like how to set up or initialize either a local one or from an existing repo. For our purposes, just come ahead and scroll down. Don't worry about those setup information. I have the commands here that'll help you do it. So some variables you'll want to set here, or just when you write the commands out, fill in. are one, the GitLab namespace. So when you create a GitLab project, your namespace is probably going to be your username. Just gave an example here of GitLabber. The repo name that you give it, right? So it doesn't matter to me what you name the repo, but it will matter for this particular step. And then the destination repo URL, right? So the URL you can actually grab from those GitLab instructions. So for me, what you're going to do is you're actually going to clone from my skeleton into a local repository on your machine. And then what you'll do is you'll do git remote-v and you'll see my skeleton repo. So we're going to change that. So we're going to reset the URL of the origin remote to your project. And then you should be able to do git remote-v and see the changes. And then do a git push, set upstream origin main, right? So basically what you're doing is you're cloning mine and then pointing over at yours, and you've got a good to go starter project repository for this step. So once that's done, just want to focus on some of the files that are in there. So the GitLab CI, right, that's going to be the pipeline file that actually calls Ansible Automation Platform. And then we've got some scripts, one for triggering the Ansible job, right? So I just use Python. It's easier for me to write that than a bash script to actually build out the post body based off of the change files and then launch an Ansible job. We've got the playbook, which is actually tied to the job template, which will do the build for us. A filter plugin, if you're curious, it just made it simpler for me to go ahead and modify some of the data as it's going through the playbook. And lastly, our definitions directory, which is going to contain your EE definitions, which we talked about in parts 1 through 3. So step 1, we're going to go into AAP, the controller, and create a project. So I've already done this, but I'll go ahead and go over to my projects tab. I've got this execution environments builder, and I'll just click edit just to show what it looks like. So I've named it. I've actually associated it with an execution environment. One of the keys here is you will want to have an execution environment that has the Red Hat certified infra.controller configuration collection and the infra.EE utilities collection. That has the modules or the role for building execution environments, as well as the role for updating controller with the execution environment information. So see, later on I'll put a link into an image that actually has that for you, and I'll host it in Quay.io that you can use if you need to. So the source control type is going to be Git, right? And you're going to point your source control URL at the repo that you've created, right? Don't point it at my skeleton repo or else this won't work very well. And then if you do have it in a private GitHub, make sure to create a source control credential and attach it here so that you can pull it from your host. And then lastly, do check update revision on launch. This is really important so that when the playbook runs, right, it has the latest versions of the definition files that you've changed, and also if you make a modification to the playbook, you want it to always have the latest. I'm going to cancel out of that, come back to our document. So we filled out this step. We also now want to go ahead and create a job template. So after you create the project, sync it, and then we'll go to job templates. Templates, sorry, not job templates. And then I've got one created here called EE Builder. So you'll probably be creating a new one. I'll click edit just to show you what I put in. Again, I've got AAP, EE Builder is the name of it. My inventory, so this is important. The inventory needs to point at an inventory that has your build host's name in it, right? So whatever host that I mentioned, I have a build server. It needs to have rel 8 with Python 3.9 to complete this process successfully. And then it just needs to be an inventory. So I have mine in this inventory called Autodotes Lab. The project is the project we just created. Execution environment, I could actually uncheck this if I wanted to, and it will inherit from the project, or I can specify it specifically for the job template. And then playbook, right? This is the only playbook in that repo, so we're going to point it there. Credentials, I put some details in the blog post for these. So we're going to need a few different credentials. 2 are custom and 2 are just basic credential types. So one is a machine. So that's going to be your SSH credential to the build server. One is a controller credential. So that's by default going to be created, and that's going to be allow you to authenticate with the controller API to update execution environment information. And then you're going to want one for private automation hub and one for EE utilities. And the reason for the EE utilities one is basically I used a credential to pass all the information into the EE utilities collection And that's for authenticating with the base registry. So like when we did this manually, those Podman login steps, as well as the destination registry. And again, the Private Automation Hub is going to be similarly for connecting to Private Automation Hub to push the images, and also to set up our Ansible.config files. So I've got documentation on how to create these custom credential types, and then it's just a matter of populating them and attaching them to your job template. Go ahead and cancel that. So the other thing that's important here is our survey. And I've got a table in the documentation for these 4 questions and how to set them up. But one of the most important ones here is that specify the build host. Give it the default value of your build server. So that's going to be the name of the host in your inventory. Here I set the execution environment version to override me. This is basically what's going to be used to tag the image. And the playbook will fail if you don't override it. So again, I'm always passing in the commit hash. And by default, the GitLab pipeline will do that. We'll pass in the commit hash as the EE version. Verbosity and cleanup, these are just kind of optional things that I was using mostly for debugging. So again, this survey is important. Go through the steps to set it up and follow kind of the instructions in the document itself. Let's go back here, right? We've got here just details about the job template fields, the 4 different credential types, the link to the credential type definition if you need to create them, and then the survey questions and kind of what to populate them in. Just to show you what I mean by the build host needing to be in the inventory, because this is really important. If I go here and I go to Autodotes Lab, and I go to hosts, see this builder host, right? Just make sure that you have that entry in the inventory that you choose that matches the default value of your survey question. So now we are going to move on to GitLab, because there's a few project variables that the pipeline is going to rely on. And if they're not set, none of this will work. So let me go over to the GitLab project, and then on the left here, and it may not be, I had pinned it, so let's go settings here down at the bottom, CI/CD. And then there's this variable section, so we can expand. And here, this is where you'll be adding variables, right? So the values here, they're going to come from kind of the same steps we were doing earlier. So your AAP host is going to be the controller host, so not to be confused with the Automation Hub host. The AAP job template ID. So if I go back to my controller, templates, I created this job template, the ID right here in the URL, 118, I'm going to put in here. And then an AAP token, right? So this is going to be an API token for authenticating with controller. Those can be created in users, and if I go to the user that I am, tokens, I can create a token here. So that's available for you to create and populate. So once you've set those up, they will be injected into the pipeline run, right? And that's so that the pipeline file doesn't have to have any sensitive information in it, and when it runs, it will leverage them as environment variables. So once you've done that, you've set up a pretty cool process. So this diagram here actually shows you what will happen once you have it set up. So as a developer, and I'll do this in a moment, what I can do is I can just push an update, and then for fun, I can go to the beach, right? Push it up to my Git repository. That's going to trigger the GitLab CI/CD pipeline, which is going to launch an Ansible job template, and it's going to detect which definition files changed, and it's going to pass that into the job template and say only build, or ignore the other definitions, only rebuild this image. Controller's then going to run the playbook right on the build host, and then your build host actually is going to be what has Ansible Builder. It's going to produce an execution environment image, and then it's going to push it up to Automation Hub, and in the same time it's going to update the controller reference to say, hey, I've got a new version of that image in Automation Hub. And so any job templates pointing to that execution environment will out of the box get this new image. So pretty cool, right? Let me show you what it looks like. So I've got this EE crash course here. I'd added some stuff to it. Let's say, you know what? I don't need the Windows content anymore. Let's make this image a little bit smaller. Add that change. And removing Windows content. And that is the extent of my manual interaction with this process. Everything else is going to happen out of the box. If I come back over here and go to my project, should be able to go to pipelines, and you'll see the pipeline ran. It was pretty quick because really all it's doing is launching an Ansible job template and passing variables, so it doesn't take very long. So if I come over to Ansible Automation Platform, go to Jobs, you'll see the first thing it did was source control update. So that's that update on launch, right? It's synced to the latest. And then it kicked off the builder process. And this will take a moment, right? Because it's actually building the image. But if we click on it and go to details, let's look at what parameters were passed in. So again, build host was passed in as builder. That came from the default value of the survey. I don't pass that in from the GitLab CI. EE tag, again, that's that EE version. That's that commit SHA for the commit, which I can always translate back to the commit itself, which is really nice. And then verbosity 0, clean out the builder directory, and then you'll notice this EE is ignore array. So it's actually ignoring the default EE and the Windows EE that I also have definition files for. And it's doing that because I didn't change them. So there's no reason to build them. If we come in here, the only one I changed was EE crash course. So that's the one it's building. So I'll go ahead and let this run, and then once it's over, we'll come back and we can take a look at the updates that were made that previously we had to do manually. All right, so our builder job template is done. I'm gonna reload the output here. Let's take a look at what happened. So if I go over to Automation Hub and I refresh, you'll see that we have a new image version. And in the pipeline, we don't actually tag, or in the playbook, we're not actually tagging with latest anymore. It's really not that important, again, because I always prefer to use the version tag anyways. So what I recommend, you don't really need a latest tag, right? You should point directly at the version itself. So we publish this. If we go over to Ansible Automation Platform, this is one of the really cool parts of the playbook, I think. If I go to EE Crash Course, it got updated too, right? So this was completely hands-free. All I did was make a change to my EE definition file, and boom, let it run. It will build the new version, publish to Automation Hub, and update controller. And that's it. You're fully automated. Take a step back. You can manage and maintain your EEs just via that definition file, and really focus on automation and writing awesome playbooks. So thanks for joining. I hope you enjoyed it. I'm completely open to feedback, so feel free to drop a comment in the video, and thanks for your time.